Now we're recording. Okay. For those of you who are listening at home, we just watched the video from the Crash Course series on stoichiometry. You should watch that. A lot of good stuff there. Okay. One of the things that he said that is really important to understanding what we're going to do in this unit is that you must go through moles first. I like to call that Moleville. Okay? Some of the key... I did not say a mountain and a molehill. I said you must go through Moleville. Moleville. No, you cannot use the restroom. Somebody else just went. When they come back, you may go. Now, some key concepts from that video. Molar mass is determined, and you figure out what is determined. Okay? You want to know what Avogadro's number is and what it's used for in terms of moles. Okay? How many of these things are in a mole specifically? Okay? Those are important things to know. You want to know what the definition of stoichiometry is. And by definition, I don't mean what does it mean in the Greek language. All right? You figure out what does it mean in the video. What does it tell you stoichiometry is? Got it? All right. Those are important concepts. Now, if you didn't get that in your notes, those of you in the class, you need to go back and watch the video. All right? Okay. Let's talk about moles. All right? You might want to get a white sheet of paper out and turn it long ways, like I've got mine turned, because we're going to talk about some stuff that are going to kind of fill up this sheet of paper, but you might be able to get it in a smaller area. It's up to you. Depends on how big you write. Okay? We're kind of making a big chart, yeah. Okay. So, if we know about this concept of the mole, we can convert from the mass of some substance we're starting with. Remember he said that stoichiometry is about measuring chemicals going into and out of a reaction, right? Okay, and how do we define reactions? We do that with a chemical equation. Okay? So, if we find the mass of one of those substances in the reaction, let's just call that substance A. Okay? Mass of substance A. Alright? If we know about the mole, we can convert from the mass of that substance to moles of that substance using the way that you calculate molar mass. How is molar mass determined? That will help you figure it out. So we can go from mass of substance A to moles of substance A. Tiara, you had a question?
Is this like in the middle or at the top right?
I put it on the far left in the middle.
Okay.
So we can go from mass of substance A to moles of substance A, or back again. And to do that, we use that thing called molar mass from the video. What is molar mass? This is going to get us from mass of one thing to moles of that thing and back again. Got that? All right? But he also told us about particles, number of particles in a mole. All right? So if we know the number of particles of substance A, using Avogadro's number properly, we can go from number of particles to the moles of that substance. Now he didn't talk about this next thing a whole lot, but he did mention how many breaths of oxygen you could use or you needed to consume. Yeah. Okay. And you might say that's a kind of a way of measuring how much oxygen is, but he wasn't measuring the mass or the number of particles. How would you measure that amount of oxygen that you breathe in? What would you use to measure that? Would you put it on a scale and measure the mass? What would you do? How would you measure that? What could you put it in to measure it? What could you put it on to measure it? Huh? What? You can. Sure you can. How do you measure the amount of a gas? Well, we could measure the mass of carbon dioxide. That's not usually the way we measure gases. Yes. Yes. Huh? Compress it. We could. We'd still have this same kind of measurement. One breath would be the volume. We could define a volume, the volume by breath. Yes, the volume of your lungs. And when they're fully inflated, maybe. Okay? So the volume of substance A.
Wait, could you weigh yourself and then take a breath and weigh yourself again?
Oh, you could do that. That's true. You might have a scale, or a balance that's sensitive enough to determine how much your weight changes when you have completely expelled all the air from your lungs and then completely inflated your lungs. Okay, it's possible. So if we know the volume of substance A, there is a way to find the moles of substance A. Okay? But that's only one of the two one of the things in a chemical reaction or chemical equation, and there's lots of chemicals in a chemical equation depending on the kind of equation. If we're talking about decomposition, you have to have at least 3 different kinds of chemicals. Synthesis, you have to have at least 3 different kinds of chemicals. If you have single replacement, how many different kind of chemicals you got to have? At least 4, because you got 2 going in and 2 coming out. How about double replacement? How many different kinds of chemicals do you have? 2 going in, 2 going out. How many chemicals is that? 4. So there's different substances, not just A. But what we can use is this mole concept to get to moles of another substance in that equation or in that reaction. So we'll call that B. Okay? And we can go from moles of substance A to moles of substance B. In Unit 1, we learned to build conversion units. Okay? You might want to get your notes back out and review conversion units from Unit 1, because we're going to be using that a lot in this unit. Okay? Review your notes from Unit 1, because we're going to be using those conversion units a lot in this unit. Okay? You're going to help yourself if you review them. Yes? 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 Can we just wait on this? Can we wait on these questions about that for right now, and we'll get to this later? Okay? I'll answer your question later. Let's stay with this, okay? All right. Now, no. It would be any one of the chemicals in a chemical equation. Well, it would be any chemical, not just carbon-12. Any chemical. Any and every, okay? Any of every, maybe, okay? All right. Now, so molar, or rather, conversion units are used for all of these. You got it? Conversion units are used for all of these. Now, does anybody remember from Unit 1 what you have to write before you can write a conversion unit? Oh, you better go back and review. Can anybody tell me what you have to write before you can write a conversion unit? You need that to make all these conversions. Okay? But from this conversion right here, from moles of A to moles B, we don't use a conversion unit. We use what's called a molar ratio. Okay? That's how we get from A to B. Molar ratio. And for molar ratios, you must, not optional, you must have a balanced chemical equation. And somebody made a note about what he said in the video about equations. They're no good unless they're balanced. Okay? If you can't balance equations, you're going to have a tough time calculating moles of B. Ain't going to happen. All right? You might get lucky. Lucky's only good in horseshoes and hand grenades. Well, that's the same thing. Close. You know. All right. All right. Well, guess what? If we have moles of substance B, we can also find the mass of that. For the same reason we can find the mass here or the moles here. So you need a conversion unit to do that. Here you need a molar ratio. Here you need a conversion unit. We can also find the number of particles. And if that substance happens to be in gaseous form, we can find the volume of the substance. All right. Now, what I just said is really key about volumes. This is if number of particles of substance B. These up here, volumes. This is if they're in gaseous form. Okay? Oh, in gaseous form. Thank you. Got all that? Yes. Yes. Yep. What do you call drawings like this? Huh? A bubble chart? A web diagram? Okay. A bubble map? Okay. No, this is definitely not a Venn diagram. Oh, it's a relation map. Okay. You can call this the mole map. The mole map. Call it the mole map. Okay. All right, now let's go back to that quote from the video that I thought was kind of cool. You must go through moles first. Look at this. Can't go from any one of these things to something else without going through moles. Okay, you see that? You can't get the mole. You can get from moles to volume and volume to moles, but you can't get anything else without going through moles. Okay? Moleville. Yeah, it's Dr. Zeus's Whoville. Okay? Yeah. Okay? And then there was a famous rock song from the 70s called Doraville, which is outside Atlanta. Okay, y'all got this? All right, let's test your knowledge of conversion units here. This is important. So, molecules are particles. Atoms are particles. Neutrons are particles. Protons are particles. Electrons are particles. Huh? 12 what? No, 12 moles are not particles. How many particles in a mole? We just saw the video. We just talked about it. How many particles in a mole? Thank you. Write that equality statement and then build the conversion unit. Okay? Can you write that as an equality statement? Can you? We learned you do it in Unit 1. We did it in Unit 10 again. No, not equals 12 moles. Because 6.022 times 10 to the 23rd particles doesn't equal 12 moles. It equals what? 1 mole. Of what? Of that thing. Well, what things are we talking about here? Molecules of carbon, of CO2. The thing here, the particles here are molecules. The thing here is CO2. Okay, yeah. Just let's write it down on paper. We're going to practice because this is really important to what we're going to be doing in this unit. Okay, let's do it. Let's go back and put the training wheels on and do the steps I asked you to do in Unit 1. Write the equality statement, then build the problem the way I taught you to do it. Okay? Okay, this many particles of anything, and the particles this time are molecules. The thing or anything is CO2. Got that? So this is our particles here. In this case, it's molecules, but it could be what? Yeah, but like what? Like what? It has to be particles of a substance, but so it could be atoms. It could be what else? What other kind of particles can be plugged in here for this, for right here? Instead of molecules, what can we plug in there? Electrons. Neutrons, protons, any kind of formula unit, any chemical formula can fit in there. That's a formula unit, okay? So that's the particles, and the thing, it's not the one from Marvel Comics, okay? This is a different thing. The thing here is CO2. It's what these particles are of, okay? If that's even good grammar, I don't know. Okay? And it equals what? One mole of that thing, and that thing is CO2. You got that? Y'all know who the Marvel Comics thing is? Yeah. Okay, good. I just want to make sure my little joke there wasn't completely lost. All right. So what are we going to do now to convert? What's the first step you're going to do to build a conversion problem? Starting amounts go first. 12.0 moles of CO2. That's your starting amount. There you go. Say what? You said it right before Breezy said it? Okay. Starting amounts go first, and they always go over 1. Remember that? Okay. So then how do we go about building a conversion unit? What do we do? Okay, got to have CO2 on the bottom. Moles on the bottom. Moles of CO2 goes to the bottom because. Yes, so y'all remember. Y'all are beginning to remember it, right? Moles on the bottom, moles on the top, cancel it out. That allows us to be able to convert. And what are we going to put on the top? There you go. There we go. We're getting it now. We're getting it together. Now what do we do? There you go. We're getting there. By the way, thanks to those guys who were willing to speak up when they were wrong. You know, you got to start somewhere, right? Yeah. And being willing to be wrong is one of the most important things a scientist does. Is being willing to be wrong. Okay? Got to do that. Got to do it. It is molecules of CO2. I just hadn't finished it out, but you noticed it before I did. Good job. Good for you. Good for you. Yes. Yes. All right. Can you do the math? You have a calculator? You could. That would work. That would certainly work. That'd be a way to do it. Well, hopefully it doesn't give it to you with 23 zeros after it. Hopefully it gives it to you in scientific notation, which is one of the benefits of scientific notation, though not required. The only time it's required that you have an answer in scientific notation is, anybody remember that?
When it asks for it.
No. Well, yeah, when it asks for it, that's true, but that's not the main thing. When you have to round off something in the ones place. All right, what you got? What'd you get?
7.226.
You didn't get more digits than that?
I got
72.22.
well 2264.
That's all the digits you got?
7.2274.
I got 72.22.
Yeah, you did. Me too.
12 times 6 is
I have
Okay, you did. Yep. There you go. Yep. So let's start with that because we want to remember how to do something else that we got to do in here.
How does 12 times 50 equal 7?
Say what? What units do we have left? Okay. Are we done? What do we still need to do? Round it off. What are we going to round it off to? 3 digits. Underline what? Underline the 6 and the 4. That has to be done. Use an arrow to show we're rounding off. What? 7.223. Good. Times 10 to the 24th because that number right here is 5 or larger. We're going to round up to 2. And just in the way of reminder, when you get to college, they may ask you to do a different rounding procedure. Okay? Yeah, one of those. Yeah. Okay, how we do? All right, y'all kind of getting it back in your memory what we're supposed to do for conversions. So we're going to take this new stuff we're learning, and we're going to apply the old stuff to it. Got that? Applying some new stuff to old stuff. Okay? All right. Let's try this one. Yeah. Yes, we do have homework tonight. Yes, if you haven't done your procedures, you got to do that too. I'm going to give you the homework in a second. Alright, so if you follow along with what we just talked about, our review from Unit 1, and you do everything the way we just talked about it and the pattern we used it now, got to be careful. You can't just stick stuff in there. You got to know what you're doing. Understand why you're doing it and the way you're doing it. You should be able to solve this problem. Okay? This is for the benefit of the people who have to leave early. Everybody's doing this one. I'll try to put the homework back up again. Right now I want you to do this problem. There's only 2 people who have to leave early that I know of. Yes. You may. You gotta stop drinking these soft drinks, guys. Man.
I love you.
I'm just talking about the number of people that asked to go to the bathroom during this period.
You is the best.
Huh?
You is the best. Everything.
You know when you get to Union, you have like a bread and the grape juice?
Yeah.
I love it. So I go behind her to get the rest. I'm like, can I have some more? So good.
You know, you can buy grape juice at the store, right? Right. And actually, that does make you go to the bathroom a lot, too. All right. I'm sorry we got off on this. Let's focus on the problem. Let's focus on the problem, please. Come on. Stay focused. Stay focused. Who's gotten the answer to this problem already? No? The process is the same. That doesn't mean you stack the conversion unit the same. Gotta be careful about how you stack the conversion unit. Okay? Oh, this right here, yes. That'd be your starting amount, yes. I prefer you just to put it in know how to put it in your calculator. There's a lot of ways to approach the problem. You can subtract the exponents and then divide the whatever the part is you call before the exponent, the base number, I suppose. Okay, you can take this number and divide it by the 6.022, then subtract the exponents. You would get the right answer. No, I don't think so. Can I move the homework out of the way? Said no. Please hurry. I can put it up later, but because I want, except for the 2 people who needed the homework, I wanted you to concentrate on the problem right now. Okay. So, Dylan and Jessica, both of y'all got the homework. All right, we'll put the homework up later. All right, now look. This is the point in the semester where it becomes really important that you learn to talk your calculator's language. And so it's really important that you have your own calculator. Okay? Because you can't do the homework if you don't have a calculator. You need your own scientific calculator and learn to use it in class and at home so when you get to the test it's not so confusing anymore. Okay? Different calculators have a slightly different way of putting numbers in when you get into complex things like this. And since you can't use cell phones on the test, you shouldn't be using cell phones for this. Even though they have calculators, programs you can upload, you need to be able to have a standalone calculator to use on the test. Okay? Yes, I can show you how I got the answer. Did you start with the starting amount over 1? All right. So what's the starting amount? 5.25 times 10 to the 20th molecules. Now, here's something that comes up sometimes. Please listen. Molecules are not moles. Molecules are not moles. Got that? What are molecules not?
Moles.
Thank you.
Moly, moly.
That's holy moly, but okay.
Roly, poly, moly.
Starting amounts go over 1. What? Has anybody tried to get this answer and just got the wrong answer from the calculator? All right, we're going to show you how to do it then. I'm going to try. Okay, what do I put on the bottom here? No, I did not put 1 mole on the bottom here because moles won't cancel molecules. Okay, I need an equality statement, guys. I taught you this in Unit 1, so listen again. This is really super important. Always write an equality statement first, then build your conversion unit. Got it? Always write an equality statement first, and then build your conversion unit. So what is the equality statement that gets me from molecules to moles? 6.022 of what? Particles of something, right? What are the particles here? The particles are molecules. Okay? The particles are molecules. What is the thing? Oxygen, O2. Alright, equals what? 1 mole of that thing, which is O2 in this case. Okay? So, this is particles. In this case, the particles are a molecule, but particles can be a lot of things. What else can they be besides molecules? Neutrons, protons, atoms, formula units, you name it. If it can be it can be a substance of some kind. Okay? Discrete individual thing, it can be a particle. And 1 mole, and here I'm trying to think again. Okay, I got to get a picture of the thing from Marvel Comics. Alright, so which side of this is going to go on the bottom? This side with the molecules, I want to be able to cancel molecules, so I want this side to be on the bottom. Alright? And what goes on the top? The other side of the equality statement goes on the top. Okay? What do I do before I solve for the problem? Solve the math. Do the math. Got to cancel. Alright, now we're ready to do the math. Yes, sir. Wait till we finish this problem. So, some of you are having problems getting it to give you this answer. And here's why. How many math operations do I have right here between my 2 thumbs? There are 2 math operations. There's a power, and then there's a multiplier. Okay? And how about down here? How many math operations? 2 of them. So if you don't know how to keep the two math operations separate from the division of those two, then the calculator doesn't know what the answer to give you. And the way you do that is you put this in parentheses and this in parentheses. Okay? So the way you put it in your calculator would look something like this. Parentheses 5.25 times 10 to the 20th, close parentheses, divided by 6.022 times 10 to the 23rd, close parentheses. Now, if you happen to have a really inexpensive calculator and you don't have parentheses, we got trouble. Okay? Now that's not to say it can't be done. It can be done, but it's a little more complex to do it. All right? When I was in high school, we didn't have calculators that would do that. We had to learn how to do it without the parentheses. Okay? And the way that works is, since I have this on the top of a fraction and this on the bottom, you subtract exponents, divide the leading terms here. I need to ask a math teacher what you call those leading terms. Okay? And then you put the whole thing back together. So you break it apart, divide the exponents, subtract the exponents, divide the leading term, then put it all back together. Okay? But a scientific calculator will make your math a lot easier. Alright? That's why one of the reasons I want you to have a scientific calculator. Another is when we get to acids and bases, you're going to have it. Alright? So you should get a much larger answer initially. Anybody put it in their calculator properly? What do you get? What'd you get? You didn't get that? Okay, but I got an 80. I didn't hear you say 8. You might have. Okay. And since we cancel molecules in O2, we have moles of O2 left. Okay. What do we need to do to get our final answer? How many digits? 3 digits. 1, 2, 3 digits here, 4 here. We want the least digits here. 3. Draw an arrow to show a rounding off. Underline the insignificant digits. Draw an arrow to show a rounding off. Then 8.72, because the 8 round makes the 1 round up, times 10 to the negative 4th moles O2. You still not getting the right answer? Same thing. Same thing. Okay. If you got this, 0.000871,803, etc., right? Let's move the decimal place 4 places to the right. 1, 2, 3, 4. There's 10 to the negative 4th right there. Now, here's how you can fix that. I bet somewhere on that calculator you've got a way of changing from standard notation to scientific notation. You have to fix every calculator set up a little bit differently. Is that a TI-80? I mean TI-30? Okay. There's probably a mode button maybe on there that'll get you back and forth. Some calculators actually have a single button that'll go from one form to a scientific and back. Good. Good. All right. In a minute. We got more to do. All right. Needed. All right, here's your next problem. Please write it down. How many moles of oxygen are needed to burn 12 moles of methane? So, I got two different substances. Can you see I have two different substances here? Look back at your notes we took today. How do I go from one substance to another? Through moles. Specifically, what kind of through moles?
Molar ratio.
A molar ratio. And where does that molar ratio come from? Balanced equations. So therefore, we must have a methane equation. Okay, that's what we think about it. Okay, what classification of equations is described? Combustion. We have a hydrocarbon, oxygen. We have a combustion reaction. It says burn. That's another word for combustion. Okay?
So when you spun out with methane,
Well, we have to write. Well, we could. Yeah, that's what you probably should do. It happens to be a gas, by the way. You don't need to know that necessarily. But you do need to know the physical state of oxygen. What is it? O2 gas. Okay? And when you have a hydrocarbon and oxygen, what are your products always going to be in here? Carbon dioxide and water. Can't believe how many people didn't get that right on the test.
So you have to balance that though?
Oh, yes, you do, because unbalanced equations are what? Useless, worthless, no good. Very good.
On the test, number 70 was like this. I could not balance if you saved my life.
Okay.
I don't know why.
I'm glad your life wasn't on the block here. Yeah.
It is on the block.
Okay.
So I never got it.
All right. Can you balance the equation? Balance it. You have it already? You got it balanced already? I thought you were dancing up there because you were balancing it. You got it balanced already. Okay. Well, I don't know. I want everybody else to have a chance. Balance the equation. This is a good chance to practice. You got to be able to do this if you're going to do the test makeup. Practice. Yeah, but I'd rather you won't. Why do you need your cell phone to go to the bathroom?
I don't know. I don't want anything bad to happen.
Oh, okay. Well, just don't.
I think mine is just in case somebody's actually
Oh?
Yeah. What if something happens?
Okay, fine, go. All right. Balance the equation, guys. What you got to do? Huh? Well, that's not what I'd start with. I'd start with hydrogen, right? You save oxygen for last? Oh, H2O. I heard somebody say O2. I'm sorry. You're right. The 2 here. That's going to give me 4 of these. It's going to give me 4 of these, and then I need a 2 in front of that. Okay, so that's balanced, right? All right, now, here's the part that we haven't done in this class yet, but it is very, very similar. Please pay attention. It's very similar to what we did in Unit 10. We took Unit 10 out of order in order to do the ice cream lab while it was still warm, remember? Yes? Wasn't that fun? Okay. So, we're going to start with our starting amount just like we did before. Okay, 12 moles of methane. But here's how you build a molar ratio. It's a ratio of moles. That doesn't sound hard, does it? Okay, good. What do I want on the bottom? Moles of what? I'm starting with CH4. I want CH4 on the bottom. Okay? Since I'm trying to find moles of oxygen, I want moles of oxygen on the top. Okay? So what we're going to do is just use the coefficients from the chemical equation for our numbers here. That's it. It's that simple. So what number is going to go here? 1 goes here, 2 goes there. Boom. Got it? 1 here, 1 here. 2 here, 2 here. Got it? Easy peasy. Why did I keep that 0? Significant digits. I got 3 significant digits here. Counting numbers don't matter when figuring out significant digits. So my final answer needs to have that same number of significant digits. How are we doing?
So, like, if you're burning calories, you're literally burning calories. Like, combustion killing.
You are releasing energy. Calories is a measurement of energy. Yes, if you're burning calories, you're releasing energy. All right, here's a new problem. Write it down, check it out. New problem, write it down, check it out. Do the math.
Like, can you go to number 3?
What? Huh? This would be single replacement. Okay. All right. No. Well, right now we're working on this problem. 5, be good. Allison, you really need to be working on these problems. Really, really. Okay? Well, good for you. Fantastic. Dylan, you really need to be working on this problem. Really, really need to be working on this problem. Yes? Sure. Work on the problem, please. Work on the problem, please. Nope. Nickel has what kind of charge number? Oh, so I need 2 chlorines. So the formula has to have NiCl2. There is no N. Oh, that's true. You're right. This is a single replacement reaction. I hear a lot of talking that has nothing to do with solving this problem. And you need all the help you can get. Practice is what you need.
Why does it start at number 3?
It doesn't start at number 3. Really? Okay. 5 times 1 divided by 1 gives you...
But what's the is it DN of DNPL2? Oh, this is
What? Somebody call my name. What you need?
No.